Hello everyone, and welcome. Today, we're going to dive into one of the most fundamental topics in electronics: how resistors behave when connected together. Resistors are components that control the flow of electricity in a circuit. But what happens when you need more than one? You can connect them in two primary ways: in series or in parallel. Understanding the difference is key to understanding how most electronic circuits work. So let's break it down, starting with resistors in series. First up, resistors in series. Let's look at the configuration. They are connected one after another in a single path. Imagine you're walking down a narrow path with several gates you must pass through, one right after the other. You can't go around them, you have to go through each one to get to the end. That's exactly how a series circuit works. As you can see in diagram A, the electric current has only one road to travel. It flows through the first resistor, R1, then immediately through R2, then R3, and finally R4, all in a single file line. There are no detours or alternative routes. Now, let's talk about current. In a series circuit, the current is the same through all resistors. Since there's only one path, the amount of electricity flowing is constant at every point in that path. Think of it like water flowing through a single pipe that has several narrow sections. The amount of water passing through the first narrow section per second is the same amount that passes through the second and the third. The flow is the same everywhere. Next, we have voltage. In a series circuit, the voltage divides across resistors. Voltage is like the electrical push or energy that the power source provides. As the current flows through each resistor, some of that energy is used up or dropped. So, the total voltage from your battery or power supply gets shared among all the resistors. The formula, V total equals V1 plus V2 plus V3 plus V4, simply means that if you add up the individual voltage drops across each resistor, you'll get the total voltage you started with. A bigger resistor will take a bigger share of the voltage. What about the total resistance? In series, it simply adds up. If each resistor is an obstacle, and you line up several obstacles in a row, the total difficulty of getting through is the sum of all the individual difficulties. So, to find the total resistance of the entire circuit, you just add the values of each resistor together. Our total equals are 1 plus or 2 plus or 3 plus or 4. The effect of this is straightforward. Adding more resistors in series results in a higher total resistance. Every time you add another resistor, you're making that single path even harder for the current to flow through. The applications include things like voltage dividers. Because the voltage is neatly divided, you can use a series circuit to tap into a specific, lower voltage from a higher voltage source. You also see them in very simple circuits. However, there's a major downside, which we see in the failure impact. If one resistor fails, the entire circuit stops. Think of old-fashioned Christmas lights. If one bulb burns out, the entire string of lights goes dark. That's because the burnt-out bulb has broken the single path, and the flow of current is completely cut off. Now, let's switch gears and look at the other side of the coin: resistors in parallel. The configuration for a parallel circuit is completely different. Here, each resistor is connected across the same 2 points, creating multiple paths. Look at diagram B. Imagine a river that splits into 4 separate streams, which all later rejoin. The current flows to a junction, splits up, and travels through all the resistors simultaneously, then merges back together. Because of this setup, the voltage is the same across all resistors. Since every resistor is connected directly to the same 2 points, they all experience the same electrical pressure, or voltage. The formula, V total equals V1, which equals V2, V3, and V4, shows this perfectly. Every resistor gets the full voltage. But what about the current? The current splits between branches. The total amount of current flowing from the source gets divided among the different paths. The path with the least resistance will get the most current. The formula, I total equals I1 plus I2 plus I3 plus I4, means that if you add up the current flowing through each individual branch, you'll get the total current that was flowing before the split. Now for the total resistance. In a parallel circuit, the total resistance decreases as you add more resistors. This might seem strange, but every new resistor in parallel provides an additional path for the current, making it easier for electricity to flow. The calculation is more complex, as you can see from the formula. 1 over R total equals 1 over R1, plus 1 over R2, plus 1 over R3, plus 1 over R4. The main takeaway is that the total resistance will always be less than the value of your smallest individual resistor. The effect is clear: more resistors in parallel lead to a lower total resistance. This unique property leads to some very important applications, most notably household wiring. Every light, socket, and appliance in your home is wired in parallel. This ensures that every device gets the full wall voltage it needs to operate correctly. And this brings us to the biggest advantage: the failure impact. In a parallel circuit, if one resistor fails, the others keep working. If a light bulb in your living room burns out, the TV and the other lamps don't turn off. The electricity simply can't flow down that one broken path anymore, but all the other paths are still available and continue to function normally. So, to summarize the key differences: in series, you have one path. The current is the same everywhere, but the voltage divides. The total resistance adds up, and if one part breaks, the whole circuit fails. In parallel, you have multiple paths. The voltage is the same everywhere, but the current divides. The total resistance decreases as you add more paths, and if one path breaks, the others stay on. Understanding whether to use a series or a parallel connection depends entirely on what you want your circuit to do. We hope this detailed breakdown has helped clear up the difference between series and parallel circuits. It's a concept that powers everything from the simplest flashlight to the complex wiring of your entire home. Thanks for watching.